In this problem, we're looking at when the forces are not in equilibrium. In other words, they're not going to balance each other out. We have an elevator with a mass of 15,000 kilograms, and it accelerates upward at a rate of 3 meters per second squared. We want to know what is the force exerted by the cable on the elevator. The reason we know it's not in equilibrium is because it says that it is accelerating. In order to be in equilibrium, it is either not moving or it is moving with a constant velocity. We still start this the same way in drawing our free body diagram. We always have a gravitational force present. That's going to be down. There is no surface since it's an elevator being lifted up by a cable, so there's no normal force. There's also no friction. But since there is a cable, there is going to be a tension force, and that is upward. The tension force is going to be larger than the gravitational force since the direction of the acceleration is upward. The next step is to write down our givens. We are given that the mass is 15,000 kilograms. And we are given the acceleration is 3 meters per second squared. The other thing that we always know this, the gravitational field strength is 9.81 newtons per every kilogram. We want to find what is the force exerted by the cable. That's the tension force. Our first step is whenever we're given the mass, we want to solve for the gravitational force. The mass usually is not much help to us when we're talking about a free body diagram with forces. So we're going to solve for that gravitational force by multiplying the mass and the gravitational field strength. The mass is 15,000 kilograms. Gravitational field strength is 9.81. And therefore, we get the gravitational force to be 147,150 newtons. Now, we are not in equilibrium, and so in order to solve this kind of equation, we're actually going to go to the second law of motion. And the second law of motion says that the total force exerted on an object is equal to the mass times the acceleration of the object. Now, for the total force, we have two of them. We have the tension, which is up, and the gravitational force, which is down. The tension, since it is up, is positive. The gravitational force, which is down, is negative. So you can either say a plus negative Fg, or you can just say minus Fg. So we're adding all those forces, but understand that since the gravitational force is down, it will be negative. For solving for Ft, we don't know that value. But we know that the gravitational force is negative 147,150. We have that the mass is 15,000. And the acceleration is 3. This then gives us that the tension force minus 147,150 is equal to 45,000. We want to add the 147,150 to the other side, since it is connected to our tension by subtraction. That gives us then that the tension force, after we add that to the other side, the tension force comes out to be 192,150. The units would be newtons. again, really the only difference here is that we start the same way with our free body diagram, our givens and find. We solve for the gravitational force if necessary, but the difference is they don't equal each other. Instead, they total together to equal m times a.